on page 651 is a blank page. You can even start if you want to on, you want to use the extra space on page 650. You can start there. We're going to do a bunch of questions with a very famous kind of question called pi over 12 questions. Now, when you think of your pi plates, which I'm done marking so I can get back to you and you're going to be able to use on your next test. If you think about your pi plate, I don't know if you noticed, but the gap between 0 and 30 was bigger than the gap between 30 and 45. There's only 15-degree difference between 30 and 45, but there's a 30-degree difference between 0 and 30. What we're going to do next is we're going to use our sum and difference formulas to be able to fill in that so we can do every 15 degrees without our calculator. But these other ones are not ones that we memorize directly. We always figure them out with formulas. So one of them, the one right between 0 and pi over 6, this one right here would be pi over 12. 75 degrees, that would be right here between 60 and 95 degrees. That would fill in that gap. And every single one of these in these gaps would have, if you changed it to radians, a 12 as a denominator and a pi on the top. That's why they're called pi over 12 questions. And there was a stretch from, well, I would say from 2003 on the final exam until 2023. There was a stretch of that where there was only, I think, 1 or maybe 2 exams without a pi over 12 question. So they are a very typical exam question that comes up, and they're usually worth 3 or 4 marks, so it's kind of nice. Again, this is very predictable. Just like the double triangle questions that we learned today, the pi over 12 questions are very predictable. So they start off like this, find the exact value. They're really easy to recognize pi over 12 questions when they're in radians, because they say cos of pi over 12. In degrees, not as easy, but if you changed it to radians, 75 degrees is 5 pi over 12. So our strategy for these. We have to use the pi families that we know from our pi plate, because these will be non-calculator questions, and they'll want you to find an exact value. So the families that we know are pi over 3, pi over 4, and pi over 6. You'll never use the axes families. It'll either be pi over 3, pi over 4, pi over 6. And you need to choose 2 of them and add or subtract to get the pi over 12 family that you want. So my first question for you is, can you see any ways you could add or subtract to get 1 pi over 12? What do you see? We could divide, but unfortunately we don't have any identities that divide. Right? There's no, we can't just take our answer and divide it by 2 because it doesn't follow one of our proofs. So we have to use adding and subtracting.
Oh, I was going to say that.
Yeah, and also we have no the only formulas that we have right now are formulas that add or subtract. So the question is, could you use 2 of these angles, pi over 3, pi over 4, pi over 6, and add or subtract and get pi over 12? Okay? Some of you see that you could do 4 pi over 12, which is pi over 3. And if you subtracted 3 pi over 12, which is pi over 4, you would get 1 pi over 12. Or you could take the 3 pi over 12 and subtract 2 pi over 12. There's often many ways you could either add or subtract to make it work. So for cos of pi over 12, the first thing I'd do is I'd pick 2 of them. So I'd say, oh, pi over 3, which is 4 pi over 12, minus pi over 4, which is 3 pi over 12. That would subtract to give me cos of 1 pi over 12. And then I would reduce these back into values from my pi plate. This is just cos of pi over 3 minus pi over 4. So pi over 3 becomes my alpha, and pi over 4 becomes my beta. And then we can just plug it into our formula. And this is where it's really nice that you're going to be able to use your pi plates on your next unit test. Because when you get pi over 12 questions, by now you probably have these all memorized. And I would still say, even though you have your pi plate, try to do it first from memory, and then use your pi plate to check, did I get it right? So cos of pi over 3, that's 1/2. Cos of pi over 4, root 2 over 2. Sine of pi over 3, root 3 over 2. And sine of pi over 4 is root 2 over 2. So I got a common denominator of 4. I can add the tops, and I will get a final answer of root 2 plus root 6 over 4. And you will find with sine and with cosine that all of your pi over 12 families always have a root 2, always have a root 6, always are divided by 4. But sometimes the root 2 is negative, sometimes the root 6 is negative, sometimes both of them are negative. In this one, both of them were positive. The root 2 is positive, the root 6 is positive, and it's all over 4. And these questions can happen in radians, or they can happen in degrees. So when we go to part B, which is 75 degrees, and I put in brackets, and I told you before, that 75 degrees is the same as 5 pi over 12. Think about your pi plate. Can you see it's pretty easy to use 45 degrees plus 30 degrees to add to 75? So again, we look for two of the angles we already know to add or subtract to get 75. And then from here, we know what our alpha is, we know what our beta is, we go to our sine alpha plus beta formula up here on the wall, and we just replace everything inside. And sine of 45 is root 2 over 2, cos of 30 is root 3 over 2, cos of 45 is root 2 over 2, and sine of 30 is 1/2, and you get your common denominator again. I'm going to give you a piece of scrap paper, take one. So our next question is going to be to find the exact value of cos of 17 pi over 12. And the reason I gave you a scrap piece of paper is because the hardest part in a pi over 12 question is to figure out two family members from your pi plate that add or subtract to equal 17 pi over 12. And I will tell you, there's actually an infinite amount of right answers. So your scrap paper is there because you each need to find one and a different one than somebody else. As soon as you find one, you'll put up your hand, I'll come check it. If it's right, I'll put it up on the board, and then that one's used up. And so sometimes someone finds one and you're like, oh, I just found that one. Now you have to find a different one. And if you find one, you're going to see, I'm only going to put one of yours up on the board, but you can see if you can find more after that. So, try to find two things from your pie plate that add or subtract to give you 17 pi over 12. The biggest hint and the easiest thing to help you with this is that if you're going to be adding two things on here, you're going to need a common denominator. Does it make sense that with pi over 3, pi over 4, and pi over 6, the common denominator is 12 for all three of those? So you can think about, when you're thinking about using pi over 3 is really 4 pi over 12. You need to have two of them add or subtract to give you 17 pi over 12. So, pause the video, you guys can get started once you find one. Okay. So we came up with 6 of them. I added a 7th one there that's crazy that you would never use, but just to show you that there are an infinite amount of them. But you only have to find one. But if we don't have a strategy for finding this one, it can take us, some of you were unable to find one, right? And you're like, I don't have, basically on a test, if this question is worth 3 or 4 marks, that tells me I should be able to do it in 3 or 4 minutes. So I need to be able to come up with one of these quickly. And we're able to come up with one of them quickly by noticing a pattern in these first 7. Okay? Now all 7 of these, if I say what do they have in common? Well, they all make 17 pi over 12. But there's something that each of the different colored ones has in common with each other that's always true. And what do we say?
They all have the pi over 4 in them?
They all have the pi over 4 in them. We always have to use, well, that's not the pi over 4. But there's the pi over 4, there's the pi over 4 in that one, there's a pi over 4 in this one, there's a pi over 4 in this one, a huge pi over 4 in that one, pi over 4, pi over 4. Okay? So what's going to happen is when figuring out a new one, oh, there was an example, an exam had sine of 23 pi over 12. Noticing this pattern that you always need a pi over 4 tells you pick any pi over 4 equals, because we need to break this up into 2 that are either adding or subtracting. So if I had 23 pi over 12, sometimes I tell students, hey, try to pick a pi over 4 that's close to 23. Which one do you want to try? Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Pick one. And it doesn't matter. And all of them are going to work. So which one did you want to pick? Pi over 4. Start off with the easiest one right at the beginning, pi over 4, which happens to be 3 pi over 12. So I write 3 pi over 12 as my first one. If I need 23, this is not hard math. Will I add or subtract to get to 23? Add. Good. And how much do I have to add to 3 to get to 23? I have to add 20. So choosing any pi over 4, right? We chose just regular pi over 4, told me 3 pi over 12. It was not hard to find the other one. And when we reduce this, obviously we already knew that that first one was pi over 4. But if I reduce 20 pi over 6, what does it reduce to? They both divide, top and bottom divides by 4, right? It reduces to 5 pi over 3. Is 5 pi over 3 on your pie plate? It is. So if you start with any pi over 4, you will always get, the second one will always be on your pie plate. So your pi over 4 is your starting point. We could finish this one. I'll finish the one that we started here, which was part C, our 17 pi over 12. I happen to choose 21 pi over 12 as my pi over 4. So what it says here, always start with pi over 4 family, and then I wrote out each pi over 4 family, what it is over 12. Pi over 4 is 3 pi over 12, 3 pi over 4 is 9 pi over 12, 5 pi over 4 is 15 pi over 12, and 7 pi over 4 is 21 pi over 12. Once you've written, so I chose the 21 pi over 12, I'm like, ooh, I have too many, I'm going to have to subtract. How many do I have to take away from 21 to make 17? I have to take away 4. And then when I reduce those down, they're always on my pi plate. All right, we'll continue with this tomorrow.